Okay, this is the P2 paper from January 2023. It's question number 3, and as we can see by looking at this, it's a binomial expansion question, but also sneakily there is some work on sequences and series in there. That's going to be an arithmetic one, arithmetic progression. We'll look at that in a second, but let's make a start with part A. Part A says, for this function here, can we find the first 4 terms ascending powers of x of the binomial expansion and give each term in its simplest form? Yeah, we should absolutely be able to do that. Let's make a start. So A. fx is given by 2 plus kx over 8 all to the power of 7, and what we're going to use is the binomial expansion a plus b to the n equals. Now I know this is actually written in the formula booklet, but you really should have done enough practice that you can just generate this yourself and get into a nice pattern when you're saying it. So it's a to the n, it's nc1, and then we just take 1 off the power of the a, add 1 on to the power of the b, and you continue with that pattern. So nc2, take 1 off the power, add 1 on to the power, and so on and so on and so on. But we're going to do that then with 2 plus kx over 8 all to the power of 7. So it becomes 2 to the power of 7, 7c1, so it's 2 to the power of 6, and just be careful with this, kx over 8, then it's 7c2, it's going to be 2 to the 5, so it's going to be kx over 8 squared, and how far have we got to go? We've got to go to a 4th term, 7c3, 2 to the 4, kx over 8 cubed. Now whenever I do one of these, what I do is a quick check before I go any further, because I'll just chuck everything into the calculator in a minute. So let's just look at our terms here. Look at the 2's. 2 to the 7, 2 to the 6, 2 to the 5, 2 to the 4. Happy with those. Let's look at the NCR bit, the 7C1, 7C1, 7C2, 7C3. Yeah, not made any mistakes there. Look at my K, kx over 8, kx over 8 squared, kx over 8 cubed, and if necessary, I mean I've already checked this now, but those 2 powers add up to be equal to 7 each time. So I don't think I've made any mistakes in generating that now, so all I need to do is to go ahead and evaluate it. You have to come up with your own method so that you are able to do this really neatly and accurately and efficiently each time when we're going through and doing it. So 2 to 7 is no problem. As I'm doing it, what I'm thinking of is, where do you students make mistakes? Quite often it's with this bit down here. Okay, it's thinking that it's, so for example this first one, it's 7c1 times 2 to the 6 divided by 8. Okay, I know it's going to be kx, so even as I'm doing this through, I know that the next one's going to be k squared x squared. I know the next one's going to be k cubed x cubed. So hopefully I'm not going to make any mistakes with those ones, and when I'm doing those, generating those coefficients, let's just jump down to this one, 7c3 times 2 to the 4, but then you've got the 8th cubed that you are dividing by. Whichever way round, you've got to make sure that you, when you're doing these practice questions, are coming up with the same answers as the mark scheme, and you're getting them every single time, and you're doing them relatively quickly. So once I've got that, that's the answer. That's the answer to part A. Find the first 4 terms. Yep, done that. Let's have a look at part B then. So part B says, given that in this binomial expansion, the coefficients of x, x squared, and x cubed, so that's that value there, that value there, and that value there, those 3 numbers, it says, are the first 3 terms of an arithmetic progression. Okay, well if that's true, let's talk to the examiner while we're doing this then. If those 3 numbers are in arithmetic progression, I'm going to write it down, 56k, 21 over 2k squared, and 35 over 32k cubed, if they're in arithmetic progression, then this one minus this one is equal to D. This one minus this one is also equal to D. So those two things are equal to each other. Let's make that clear to the examiner. What we're saying is, let's write it here, 21k squared over 2 minus 56k, that's equal to D. But 35 over 32k cubed minus 21k squared over 2, that's also equal to D. The common difference in the arithmetic sequence there, arithmetic progression, sorry. So that minus that is D, that minus that is D. Those two then are equal to each other. Now I've got every faith here, it looks like it's going to be complicated, but this will just fall out now. It's not going to make something that I can't do here. So if we've got that situation, let's get everything onto one side. It looks horrible, but it'll work out. No worries about that. I've got 35k cubed over 32 minus 21k squared. Then you've got 2 over 2 twice. Plus 56k is equal to 0. I've just taken everything over to that side. Right, we can see that k comes out as a factor. Excuse me, I'm going to multiply everything by 32 first of all. So I'll get 35k cubed minus, 672k squared plus 1792k equals 0. But then we can take k out as a factor, and actually if you look at that you can take 7 out as a factor as well. Is going to give me 5k squared minus 96k plus 256 is equal to 0. So that's either going to give me k equals 0 there, or solving this quadratic. Now just quickly looking at this quadratic, they sort of expect us to be able to factorise this, and if you want to take the long method, the AC method of factorising it, you can do. I'm not going to do that here. I've done that in previous videos. Or you can use the quadratic formula, but either way, this is going to drop out as nice, neat answers. It's entirely up to you which way round you do it. There'll be some of you that can also just factorise it by looking and trying to work out what the values are there. These are pretty unrealistic to be able to get the factors of 256 or 16 or minus 16 and minus 16. If it were me, I'd quickly chuck it into the formula, get the answers, and then maybe come back and do this bit. But so either we get 5k equals 16, k equals 16 over 5, or k minus 16, so k equals 16 there. Let's just see, can we have k equals 0? No, you can't have k equals 0 because otherwise the thing wouldn't make any sense. So the two possible values are those two there, don't include that one. So not included, just to make it really, really clear that it's those two that are the answers. Okay, so yeah, that's a binomial expansion and arithmetic progressions all in the same question there. Hopefully that all makes sense to you all.